everyone, Kieran Sapien here from Filmstorm Studios, and welcome to another exciting tutorial. Today we're going to have a look at creating a movement system totally inside of C#, inside of Unity. And let's get started. Let's have a little look at what we've got set up so far. So if I press play, we've put our Filmstorm camera system in, and as you can see, if I look around and I try and press on the keyboard like WSAD, we're not moving anywhere. But we have our animations all set up. We don't need to cover that side of it. Let me just quickly show you what is happening. We've got a free move blend tree, and all this is just an input magnitude, which is really only driving it because the other part of it's punching, but we're not going to worry about that. So if I press play and we drag between 0 and 1, you can see he's walking or he's idling, and that's pretty much it. So how do we actually drive this to make 360-degree movement? Well, let's get started in developing that script. And the only thing you need to make sure you have inside your animator is the blend tree with the input magnitude. You can even have it on 1D, but most of my blend trees have different variables, so that's fine. But you can just have it on 1D with input magnitude. Make sure in your parameters you have an input magnitude, because that's all you need to get this to work. All right, to get started, let's click on our player. Let's create a new component, and let's call this movement input. New script, C#, create an add. Excellent, that's just gonna take a second. And here we go. So, what do we need to do first? Well, what we want to actually get started doing is just declaring some of our variables. So let's go public float, and let's make it input x, public float input z. We want a public vector, we want it to be a 3, and we want to call this desired move direction, which is going to be which way we want the player to move. We want a public bool to block the rotation of the player. This is handy if later on you want to actually have different move off cycles. So if you want the player to move forward with a starting animation, or you want him to move backwards, this is what you can trigger to turn it off and on. Public float, and we want to call this desired rotation speed. We want public animator, and we want to call it anim. We want public float speed, public float allow player rotation. So this is usually so we can compare the speed to the allow player rotation to say when you want the player to start rotating. We want a public camera. This is so we can get the input direction that we want the player to move. We want a public character controller, and we want to call this just controller. 3 more. We need public bool for is grounded. We want a private float, and we want to call this the vertical vel, or velocity. We want a private vector 3, and we want to call this the move vector. And you can see the naming conventions I'm actually using here. Every first letter is lowercase, and then each word after that is actually uppercase. So if I just save this script, come over here, you'll notice that it will separate them into spaces, and that's a really good way to code, so that way it makes a lot of sense. If you don't do it that way, if you have everything lowercase or uppercase, it's not going to be able to recognize what you mean. But putting lowercase first and then uppercase for each other word, it will actually separate the words really nicely for you. Okie dokie, now let's get started with our starting method. We want to declare the anim, which is pretty simple. We just want to get this component. So you have to make sure that whatever script this is on, it's on the actual animation component. We want to declare the cam that we made, and we're going to just call this the camera.main. So you have to make sure your camera has the main tag on it. So let's just go over to camera. So you see how it has main camera? You have to make sure that's on it. Okay, let's go back to here. And finally, we need to declare our character controller. So let's go controller is equal to, again, this dot component character controller, and done. All right, now let's go on to our update method. Very simply, well, actually first, let's just make the other methods that we're gonna need. So we're gonna make one called method player move and rotation. So this is actually gonna move the player. So let's just close that out. And let's create another one called input magnitude and close that one out. So we'll come and fill these ones in later, but let's just get this update finished. So what we want to do is call the input magnitude. So every time the update is called, which is very regular, it's going to keep calling that input magnitude, which will then drive our player move and rotation. So finally, what we want to do is make sure our player sticks to the ground. If you don't need this, then you can get rid of it. But I find that sometimes your character controllers can start floating up into the air or do really weird things. So if you like him to be grounded, you can just tweak the code, put another bool in to turn it off and on when you need it. But I'll just show you how this is coded. So is grounded is equal to controller dot is grounded. Good. Now, if we say if is grounded, so if the character is grounded, what do we want to do? We want to say the vertical, that vertical vel is less than or equal to, or it can, so it's not less than, it actually means that it can't be equal and it will only be less than. So, so make that 0, or oops, we want to make sure that is else. So if this is not true, we want to say then the vertical vel is 2. So that it means it's going to push the character down to 0, and if it's on 0, then we're going to be grounded. So technically that's how we're going to push them. All right, so now we need to make our move vector, and we want to move that vector with a new vector 3, and we want to move that new vector 3 with that new vertical valve that we made, close that out, and then we want to move the controller.move in that new vector, and that will keep your character nice and grounded. So again, if you don't need this, if you don't need the character grounded, then get rid of this part and just delete it up to here. So get rid of everything in between. Cool. Now let's move on to our player move and rotation. Alrighty, so what we want to set up first is the input x, which is input is equal to input.getAxis, and that's going to be our horizontal axis. Close that, and we want the input z, which is input.getAxis, and that is the vertical. So technically that's our backwards and forwards and left and right. Now we want to put some variables down. We want to say camera is equal to camera.main. Variable forward is equal to the cam.transform.forward. You probably don't need that first one because I think we already declared that above it, so we can get rid of that in a second. So let's just put this in. So we want forward is equal to cam transform forward, and right is cam transform right. And technically this is actually turning into a vector 3. So even if you change this to a vector 3, that will be good. But using vars can make your life quicker, so you're not trying to think of everything that you need to be using. All right, so now that we have those set up, we want to declare that forward.y is equal to 0f, and right.y is equal to 0.f. We want to get the forward.normalize, and we want to just declare that, and we also want to normalize this right one as well. Excellent. So this will just it would actually change the coordinates into a system that will allow us to use this next part. So we want to say get that desired move direction, and we want to go forward times the input z, so how much are we pushing forward, then we'll get that forward position. And we want to plus the right by the input x, so the left or right. So see how we're going left and right, and the right one can also be left if it's a negative value as well. So that's that. Excellent. So now we want to just put in that if the block of the rotations block rotation player is equal to false, so you don't want to block the rotation of the player, then we can move the rotation of the player. So we're able to rotate him. We want to say transform.rotation is equal to quaternion is equal to .slurp transform.rotation, and then we want another quaternion dot rotation, and let's whack in a desired move direction with the desired rotation. So this is actually going to make our guy look in the correct thing. Let me just make this wider for us. Excellent. Okay, so this is basically, wow, 3.84 gigs. Look at that. So we've got all of this looking really good. That should be all working, although it's giving me some problem here. Quaternion, because it's not a quaternion, it's a quaternion. There we go, that looks better. So make sure that is spelled correctly. And that is our first method complete. So we have the player and move rotation done. Let's move on to the input magnitude. All right, so let's just make a little comment. We want to say calculate the input vectors. Excellent. So we want to say the input x is equal to input.getAxis. So basically this is the same from above. So maybe to save time, let's just go up here and grab these two and whack that in down there. Cool. Now let's go anim.setFloat. So we want to set the float, and so we're actually going to be setting the input z as well, so you can use this later. So input z 0.0, and we want to make this time.delta time times 2 to just help it speed up a little bit. Let's just copy this one and paste it, and let's just make this x. So let me just quickly show you what's happening here. So in this parameter, you want to make sure these two are in, and also as well as making that input magnitude, make sure that's in there. So that's the only ones you need for that one. All right, so moving on. Now we want to calculate the input magnitude. So we want to calculate how much the player is pressing the keys, or I mean, with a keyboard, it goes from 0 to 1 instantly. But if you're using a controller, which this system also allows automatically because you're using the axes rather than a button press, you can actually interpolate between the two numbers. So I can go 0, 0.1, 0.2, and that way you can actually get really nice blends between your character. And also with this, you can actually dampen the time. So see how we have 0, 0, and 0, 0? You can actually make it like 0.3. So that if you use a keyboard, it will actually take a bit of time to snap into position, so the player doesn't just instantly go into an animation. All right, so now that that's explained, let's go into our calculate the input magnitude. So let's say the speed is now equal to a u vector 2. We want to say the input x and the input z, because we want to get the magnitude between it, and we want to get the square magnitude. Oh, don't close that out, and look at that. Now we're getting that. Now if we want to physically move the player, so this way we're going to actually be talking to the system and allow it to actually enable this method, because you can see that we haven't actually called this method anywhere. The only one that's running constantly is our input magnitude, and this is the one that does all our calculations. Okie dokie, so we've got physically move. So let's go if the speed is greater than allow player rotation. So make this, we want to say anim.setFloat is the input magnitude. I want to make sure that's spelled correctly. And we want to set it to the speed. We want to set it to 0.0f. And at the time, time.delta time. And that is that. And we also now, if the speed is greater than the allow player rotation, we also want to be moving. So if we're moving, then we want to be calling this method that we just made. So we can come down to here, inside of the if, and say player, move and rotation, and we want to start to enable that. Because if the update is constantly calling, the input magnitude is constantly calling and running, and then this is true, then this will be constantly calling and running, which will then drive the player to actually move. So that is really, really cool. So now let's go to else if, so if it isn't doing what we want, if the speed is less than allowing the player to rotate, then we just want to set the anim set float the input magnitude to the speed 0.0f time.delta time, and close that out. So you can see that even though we're not going to be moving the player if he's less than the allowed player rotation, then we still have to update the input magnitude, otherwise it will get stuck in some random value. And apart from that, we now have our full movement script all done. So I'll just leave it, I'll just quickly scroll through it slowly in case you missed anything. You can pause the video at any spot. All right, almost there. And that's it at the bottom. All right, and I'll also be putting this on our GitHub. I'll be putting down the link. I realized I probably should have been doing this for quite a while, but now you'll be able to go back and look at all the scripts. I'm slowly going through and pulling all the scripts I've been making and popping them online. So that should be good. And I'm almost gotten Filmstorm.net back online as well. So you'll be able to go check that out. All right, but getting back on track, let's jump back to our scene. And let's go to our player. All right, so if we just click play, let's see what's gonna happen without adjusting anything. All right, so I'm pushing right actually, but he's going forward. So this is gonna be because the allowed player rotation is actually set to 0. So if we set this to 0.1, let's have a look what happens now. It is still nothing, so. Oh, well, actually, there's one more variable that we need to set up. Okay, so if you set that back to 0, see desired rotation speed? Let's make that 0.1, because actually his rotation speed right now is 0. And there you go. We are now moving the character. You stop and see how he moves relative to the camera, which way we're pointing. So if I look this way, he's going to turn and turn there. Turn and turn there. Okay, and now if we change this to 0.05, say, and then we rotate, see how he takes a bit longer? We can even go a lot slower. Okay, there we go. So let's make him do this. And I'm pressing down, but you can see how long he takes to turn. It's not very responsive. So if we make this even 1, you'll begin to see how it's like it's almost instant. So I find 0.1 is a good value to use. It feels pretty smooth. And yeah, so that's pretty much it. And so, like I was saying, with this allow player rotation, I got mixed up between the desired rotation speed. This, say you want 0.3, he won't start to move until he gets to 0.3. So then you can actually put an animation in to start to blend him off in the direction you're moving. So say you have start backwards, he'll turn with that animation start and then re-blend back into this blend tree. And that's really helpful for focusing. And then also we set up that global block rotation of the player. So if you tick that, which you can control in any of the code, and now I'm pressing left and right, he can't turn anywhere because that's blocked. But if I turn that off, now you can see we can move again. So that is how you set up a very simple movement input, completely using script that's responsive to the camera, so whichever, or actually relative to the camera is the better word. So as you can see, even if I'm looking this way, looking directly up, it actually gets a world plane on that X and Y. It's not actually affected by looking directly up. So you can see even if I look directly down, push backwards, looking left and right, everything works perfectly. And the camera system is actually using the Filmstorm camera system. So you can see we've got the camera follow, and we've also got that Filmstorm camera here with that collision. And I actually altered the script in the camera collision to use just a separate layer, but we can go over that, or you can check out my GitHub again to find that script. It's in the camera system. But thank you everyone for watching. I hope you found this very informative. I believe it was a fairly long episode, 20 minutes roughly. So thank you all for watching. I'll catch you guys in the next tutorial. See ya.